Hello and welcome to the SeETL presentation for IT project managers about SeETL, the world's most productive ETL tool. My name is Peter Nolan and I'm the founder of Instant Business Intelligence. In this presentation, which will go for about an hour, we're going to cover the following areas. We're going to talk about ETL and where it's been up to over the last 20 years. We're going to talk about what is SeETL, who is SeETL intended for. We're going to talk about the two components of SeETL that exist today. There is a design time component and a runtime component. We'll talk a little bit about how much is SeETL and how much a client's paying for it. And we'll go through the normal reasons for why would I buy this product called SeETL. And then how do I find out more about this product. But in the beginning, let's talk about ETL. It's been going on for a long time. How much ETL is there in a BI project? Well, it depends on the BI project and how complicated it is, but you can be prepared to spend something between 50 and 70% of your 5-year budget on support for the ETL subsystem and the data model. That is our experience. Nearly everything to do with the cost of ETL, apart from license fees, and ETL license fees have gotten much larger over the last 10 years, most of the cost will be people time for the changes to the ETL subsystem, particularly in testing and promotion of code into production and changes of code in production, etc. What we are finding within data warehouses is that the rate of change of data in data warehouses, data structures, continues to increase rapidly. The amount of change to data warehouses is increasing rapidly, and therefore the cost of alterations to the ETL subsystems is also increasing rapidly. We are seeing that companies are building data warehouses with more fields, and more fields means more ETL. It's almost a straight line. Now, ETL tools that have been brought out, the Informaticas and data stages of the world, are bringing down the percentage of the time being spent on building ETL subsystems. In response, of course, the vendors of these tools are increasing their prices. The other area where increased prices is changing this percentage a bit are BI tools. Microsoft and others have brought out fairly low-cost BI tools, but the top three, Business Objects, MicroStrategy and Cognos, are still quite expensive tools. And so higher priced BI tools are also changing this ratio. However, you can expect to spend something like 50% of your total 5-year cost of ownership of your business intelligence system on ETL. What are the issues on a BI project? Well, there are many issues, but one of the main issues is that as more source systems are introduced, the ETL becomes more complex. There is more data to understand and move, and the effort to do this work increases dramatically over time as more source systems are added. What we are now finding with the construction of very numerous fields, large data warehouses with lots of fields, and we're talking 4,000 fields for a version 1 data warehouse, is that coming to understand the data in the data warehouse is becoming more and more difficult. It's becoming more and more difficult for an individual person or two people to retain inside their head the meaning of the data that is going into the data warehouse. Because of this complexity, there has been a desire to create ETL tools which help the ETL designers and developers manage the problem of writing all this software to get data from operational systems over into a data warehouse where it can be restructured for query and analysis processing. As the ETL load and workload, that is, slows down the delivery of the schedule, you tend to get something like the following. A big difference between what is expected and what is delivered. Initially, many business people think they're going to get a nice tower like the one on the right-hand side of the screen. And alas, What turns up is something that is a tower, it is tall, but it's not quite what was being imagined by the business people. And oftentimes you find that the business people are relatively unhappy with what is being delivered, despite the best efforts of the IT people in building the data warehouse. Now, I've been building ETL since 1991, and we use COBOL. And this is what it's like to build ETL subsystems without a decent ETL tool. This is actually a small town in Norway, and I thought it was a lovely postcard, and so I scanned it and put it into this presentation. Life without an ETL tool on a data warehouse project is a little bit like being sent to hell. So if you don't want to use COBOL and you don't want to go to hell, what are your options? Well, you can buy an ETL tool from one of the many vendors. There's more and more of them out there. DataStage, Informatica, Sagent, I think has been swallowed up, Ab Initio, Microsoft's SSIS, Warehouse Builder, you name it. There are ETL tools out there from all the major vendors, as well as some niche ETL tool providers. Now these tools will cost you some money, and some more money now for less money in development later. And all these tools have their strengths and their weaknesses, which is why they all have their own place in the marketplace. Now you could also write the ETL code yourself, and still very many customers do this, in which case you'll be wondering, what language should I use, C or C++, or if you're Oracle, will you use PLSQL or stored procedures, or surprise, surprise, some people continue to use COBOL. COBOL's not going away anytime soon. And of course, if you can get some sample code and learn off that sample code, which is widely available now, you can build your own ETL subsystems out of your own ETL code. And now, and we should say for quite some years now, you could also use our tool, which is called SeETL. So what is SeETL? What are we talking about? Well, for a start, SeETL is easily the world's most productive ETL tool. You will find nothing else available to you which gets you from design or staging area design to working ETL as quickly as SeETL. As quickly and as cheaply as SeETL, I might say. So there are two major components. The first component is called SeETL Design Time. This is a tool where you design the mappings that are going to be implemented into production. And it is done at design and analysis time. So we have a worksheet, an Excel worksheet, which captures all the ETL rules, and it defines all the source to target mappings, but it defines many other areas as well. And we have a 70-minute presentation on what are the pages in the SeETL workbook, and there is a very long manual, 200-page manual, talking about what are the pages in the SeETL workbook. So you're welcome to go and review all the pages in the SeETL workbook, and there are example workbooks on the website. The design time software is used. The design time software takes a spreadsheet data and actually also loads it into the dictionary, the SeETL metadata dictionary. And so we have a dictionary which covers many areas of the ETL subsystem now. The current version of SeETL Design Time is also able to generate SQL and express the ETL subsystem as SQL and put that SQL directly into the database. That is a new feature, so the Design Time module can generate the ETL subsystem as SQL if that's what you want, and that's a big feature. And we have a 1-hour presentation which shows you exactly how the SQL is generated and what the generated SQL looks like. The other component is called SeETL Runtime. Now, SeETL Runtime was the earlier version of this software, and this was produced under the assumption that the databases could not perform the ETL processing, and that the ETL processing is best done in C++ outside the database based on flat files. And of course that assumption was very true in 2002. So SeETL runtime includes a scheduler, which is a very robust scheduler which gives the SeETL administrator a great deal of flexibility about load balancing for the schedule, as well as individual programs that run which perform each type of processing. So let's say, for example, you have type 1 dimensions and you have type 2 dimensions. Well, there are two programs that one does type 1 dimensions and one does type 2 dimensions. So these C++ programs, there's about 80,000 lines of C++ in the product. These C++ programs run under the control of the scheduler to perform the ETL of the ETL subsystem. So what you have today is two options. You can use the C++ engine, or you can generate the ETL subsystem as SQL statements. That's really up to you. Now, the runtime engine logs all processing of SeETL into reports and exposes all that processing for you. So there is a great deal of audit information when running the ETL subsystem using SeETL. So, how does SeETL work? Fundamentally, you enter all the source and target mapping, quote, mapping definitions into the design time spreadsheet. You set a set of values on the processing tab and what actions you want SeETL design time to perform, and it will load data into the SeETL control database, or it will generate views and do other things depending on the processing tab and the actions you have asked SeETL design time to perform. You then run this simple 3-button Visual Basic application to open the spreadsheet, process the spreadsheet, and close the spreadsheet. And some customers have changed that to a command line application so they can just run it as a command line and it performs the processing requested. If you generated views or tables or other database objects, we don't apply those changes to the database directly. We expect the DBA to take a look at the output and make sure that it is correct, and then cut and paste the changes to the database into whatever tool the DBA likes to use to maintain databases. And all DBAs have their own suite of their favorite tools that they like to use, and we expect them to continue to use those tools rather than to use ours. So then there is the SeETL runtime. Now, SeETL runtime, as mentioned, is a C++ engine, and what the scheduler does is it just sits there and waits for some prerequisites to be met. When whatever prerequisites that are defined are met, the scheduler will start the batch for that set of met prerequisites. The scheduler can run any command that is valid to run on the operating system on which the scheduler is running. So the scheduler has run in Windows and Linux and Solaris and AIX and all these different sort of operating systems. So whatever else can run under that operating system can be started by the scheduler. And one good example is that data stage jobs can be started by the scheduler. And we have had experience where by using the load balancing techniques of the scheduler, we were able to get the same suite of data stage jobs to run in about 30% less time than the data stage scheduler could get the jobs to run. And that was specifically because we were able to load balance the machine to maximize the throughput of that machine without sending that machine into a thrashing state. So that was a rather nice thing to be able to do. Now, why is SeETL so productive? We make the claim that it's the most productive and cost-efficient ETL tool. And it is. So how can we claim that? Well, all BI projects must first define their source-to-target mappings. That is, you're going to take data from a variety of different operational systems maybe flat files, maybe feeds from other places, and you're going to propagate them into some form of data warehouse. Now you may do that through a staging area or not. That warehouse may be dimensional or not, but the warehouse will be a separate database and it will require data movement from operational systems into the data warehouse. Today, that definition of those data movements is usually done in a spreadsheet during the design time. That is, some analysts must take a look at the data that's coming into the data warehouse, and they must document where that data is going to go, what transformations need to be done to it, what integration steps need to be done to it, etc. Now, SeETL provides such a mapping spreadsheet in which you can define all the transformations that are necessary to go from the staging area to the target. Now we just call it staging and target now. So we provide a spreadsheet which is very handy, very useful, and it can be used as documentation, and you can use it only for documentation, and that's fine. However, what we have invented, and we did this as long ago as 2004, is the ability to read that spreadsheet using Visual Basic and generate everything that is necessary to be generated to implement the ETL subsystem. We also had the 80,000 odd lines of C++, which represents the ETL engine and all the different processing steps that can be performed. And the SeETL workbook can have a schedule typed into it, which then schedules the data movement processing for the ETL subsystem. So the important thing to understand is there is no coding or translation step from the mapping spreadsheet to the ETL tool, and we are the only people who can do that for the entire ETL subsystem. Now, everybody else is having an analyst of some sort define the movement and transformation of data from a source system to a target, and then giving that information to a programmer to put into the ETL tool of choice. We are the only people who can say the designer does all the design work, and what comes out of the design work is the executable code with no programming step. And we can do that for well over 99% of cases. SeETL is productive because it does this translation step automatically from design or documentation to executable. That is automatic. Therefore, SeETL will remain the world's most productive ETL tool because there is no faster way to do ETL other than to have an analyst determine where the data should go and what changes should be made, type that into a spreadsheet, which is the easiest tool of all to use, and that's the end of the coding phase as well. So SeETL is about 10 times more productive at about 10% of the price of the mainstream ETL tools. Fundamentally, we've created the better mousetrap. So who is SeETL intended for? Well, SeETL is intended for companies who fit into the following categories. One, you are building a BI system on a tight budget, and that's a lot of the companies that are out there now during this latest financial crisis. I remember talking about the recession and financial crisis in 2003-04, and talking about how SeETL, or the predecessor to SeETL, was a really good idea during the current recession financial crisis. Then we had some more boom years in 5, 6 and 7, and then 2008 we're back to the recessionary years again and financial crisis. So if you want to build a BI system and spend as little money as possible, SeETL is a good option. If you have decided not to purchase an ETL tool, SeETL is a good way of getting an ETL tool that is very simple and straightforward to use, and avoiding writing all this code for yourself. If you have already bought an ETL tool, and the normal examples are Informatica and DataStage, and you want to augment the development process of using those ETL tools with the features of SeETL, then that's actually a good move as well. We are able to prototype ETL subsystems much more quickly than you can in DataStage or Informatica, and we have also developed a method of taking SeETL mappings and converting them to DataStage or Informatica very quickly. Also, if you would prefer to minimize the amount of code you have to write to build the BI system, SeETL is a good idea because there is no code to write in your ETL system. Virtually all the code that gets written in an SeETL ETL subsystem is the code that goes into the source view definitions. So you are actually creating the ETL subsystem in the source view definitions, and everything that's available inside the database as a source view definition is what you are doing your ETL subsystem with. So what will SeETL do for me? SeETL, very simply, will save you time and money and existing company resources over doing ETL any other way. It will enable you to develop BI systems faster, cheaper, more easily and more reliably than ever before. One of the things that we are finding with SeETL as an ETL subsystem is that the ability to hit targets for development processes is vastly improved because of the simplicity of what is being done, and the production ETL subsystem also generally vastly increases in reliability because all the complexity and processing is being pushed into the database, and the databases are far more reliable in performing complex processing than virtually any other piece of technology. The database vendors spend billions of dollars in research and development and reliability and testing of their databases. Orders of magnitude more money is spent on testing databases than testing ETL tools and ETL tool upgrades. So therefore, the more work that is pushed into the database, the more reliable the ETL subsystem becomes. SeETL will automatically and dramatically reduce the elapsed times of making new data available, and it will reduce the cost of making new data available into an existing data warehouse. SeETL will also dramatically improve your ability to run specialized short-term analysis. What do we mean by this? So let's say you have some very specific need to run short-term analysis, but only for a short-term period. If you take that need and you try and get an estimate from your IT people about how much it's going to cost and how long it's going to take, it may be going to cost too much and take too long, and therefore it won't be done. However, with using SeETL, because it will cost less and take less time, it becomes more viable to run these short-term specialized analysis or one-off analysis. SeETL will also improve your ability to add new summaries of information to improve performance for queries you run on a regular basis. The C++ SeETL engine is fully multi-level aware, and you can add summary levels into it with no coding changes. So let's get into SeETL design time for details. Every BI project must define source to target mappings. As we said, today that's usually defined in spreadsheets. Every project must convert the quote documentation to a set of code in the various tools. So, for example, tables and views and indexes must then be moved to some kind of modeling tool. Commands and scripts and schedulers have to go into the schedulers. Transformations have to go into the ETL tools or into some kind of code. So during the whole mapping, writing or design definition process, all these things have to be done. If there's stored procedures, where are they? Where are they stored? Where are they documented? If there's functions, where are they stored? Where are they documented? All the reports that get written, where's the documentation for the reports? If you have multiple reporting tools, Where's the documentation for all those reporting tools? When you run your project plans, where's the documentation for those project plans stored? How is that communicated out? So all these things must happen on a BI project. Then after that, every project suffers the documentation and code getting out of sync problem. So we all know that if your documentation is separate to your code and you say to your programmers, you must keep this documentation up to date and in sync with your code, we know that you're being very hopeful. Let's put it as gently as you're being very hopeful. So as the code changes away from the design specifications, you get to undocumented code. And the only way to understand what the code is really doing is to read the code, not the documentation. Now, as code gets more and more undocumented, or as the documentation diverges further and further away from the code that is in production, you get to an increased rate of errors, you get to patches being put onto the code by people that don't really understand what the code is all about, and you get more undocumented code. And this leads to the rather endless maintenance of undocumented code. Projects suffer this even when you've gone to the trouble of going out and buying a metadata tool. And so all these BI projects are suffering, or many BI projects are suffering, the alignment between documentation and executable code problem. And how much does this problem cost? Well, Frederick Brooks first said that when you put a system into production, you have consumed approximately 20% of your budget for that system, and the other 80% of the budget for that system was yet to be expended. And that seems about right for ETL subsystems as well. So it's hard to say exactly what the cost of the code divergent from documentation problem is, but it could well be that coding of the mapping documentation is easily 20% of the total cost of the project, just getting started on the project, not worrying about the maintenance. The maintenance of code is easily 20% of the annual running cost of a large warehouse, including fees, although experience has shown that it can be significantly higher as well. There is a significant frustration in the data warehouse team and end user team that bad code keeps happening in ETL subsystems. You can go and talk to other people who've implemented ETL subsystems or other IT managers who've implemented ETL subsystems, and you'll consistently hear that bugs in the ETL subsystem are a very significant area of frustration. Now, we would be pleased to hear other people's opinion on the cost and experience with this problem. We have a set of forums which people are welcome to come and talk on. So on a $1 million warehouse project, you should expect that the cost of ETL will be $200K during the project, if not significantly more, and $100K per annum, if not significantly more. Now, on larger, more complex projects, you should expect the ETL cost to be significantly larger. So what is the solution to this problem? The solution to all coding problems has always been, and will always be, generate as much code as possible. So ETL is no different. The more code you can generate from definitions which are templated, standardized, known to work definitions, the better off you're going to be. So we wondered for many years, was it possible to use the mapping spreadsheet as the source code for generating ETL? All this cutting and pasting that we were doing did seem to be a little bit like repetitive work, but we didn't know whether we could actually do that somehow more mechanically. We didn't see it was feasible until approximately 2004. So the solution to this problem, the question was, is it possible to use the mapping spreadsheet as a source for generating ETL code? And the answer is yes, it is possible. And we first did that in 2004, 8 years ago. So we have seen the future. We saw it in 2004, and it is generated ETL. Once the source for all ETL and all code is generated, what do you have? You'll have a mapping spreadsheet workbook to define all ETL code. You'll generate the code from the spreadsheet. The mapping spreadsheet is permanently, quote, in sync with the code because the code is generated from the spreadsheet. The only person who needs to understand everything in that spreadsheet is the data warehouse architect. And the data warehouse architect defines everything that's necessary in those mappings. What we have been seeing over the last 4 or 5 years is we've had numerous clients try and get us to train many people to do the mapping for a data warehouse. And this is what I now refer to as the communization of the workplace. People are saying everybody needs to be able to do a little bit of everything. And if we're all equal and we're all equally skilled, then anybody can do anything, and people are interchangeable in doing things in IT projects. This is what communization means. Now, I disagree with that idea. What we have found is that people who become very skilled at data analysis and data mapping do that job significantly better than people who are far less skilled at that. And this comes as no surprise to me. The same holds true for writing any kind of coding language. If a person spends years learning their trade of learning how to write a particular language very, very well, and reads up a lot on defined algorithms in this language, and learns from other people about how to do things the best way in this language, they turn out to be far more skilled than somebody who is, quote, far less skilled and has spent far less time and effort learning their trade. Why this would be a surprise to anybody, I'm not sure, but this is what we see. So we see that it is far more productive to have as highly skilled person as possible looking after the data modeling and ETL subsystem. And that makes the data model and ETL subsystem far more reliable than getting a larger number of less skilled people to do the same job. So what we see is only the data warehouse architect needs to define and understand the mappings to any significant level, and then the documentation for those mappings is published and other people can read them. The spreadsheet also defines all the commands and the job streams and everything else. The spreadsheet can be analyzed and reported on because it's saved as an XML document, as well as everything in the spreadsheet gets loaded into the metadata dictionary and therefore can be analyzed and worked on from inside the metadata dictionary. The metadata dictionary is also versioned, and so you can actually see what was implemented in a version of ETL as well, much more easily than you can in, say, an Informatica or data stage implementation. Now, what is the value of this solution? We have been at this specific generated solution now for 8 years, as well as using various versions of the predecessor products right back through to the mid-90s. So we can say with all confidence that the cost savings of using SeETL, even if you use another ETL tool in production, which many of our clients have done, the cost savings are huge. And our experience has been roughly 50% of the ETL cost is taken out of the project. So if the ETL cost for the overall project, 5-year total cost of ownership, runs at about 50%, then we're talking about saving about 25% of the total cost of ownership over a 5-year period. So using SeETL, you should be looking at saving 20 to 25% of the total cost of ownership for a 5-year cost for a business intelligence project. That's what we would stake our name on. So the mapping spreadsheet is permanently in sync with the code, and this eliminates all ETL programming and maintenance efforts in terms of no effort to maintain any software. It eliminates all the confusion between which is right, the documentation or the code, because we know the code is always right, but in this case the documentation and the code is the one and the same thing. The ability to rewrite any quote ETL report from the mapping spreadsheet. So it's actually possible to look into the mapping spreadsheet, load it into the metadata dictionary, and get reporting information out of that to analyze and understand the ETL subsystem. And another thing that we have found is that when mass changes during the development of the ETL subsystems, when mass changes are required to alter naming standards or something else like that, what would have taken a great deal of time in a data stage or Informatica environment will only take hours in a SeETL environment. And one of the good examples of this was for one client where we had over 200 mappings into the staging area. We had a naming standard change enforced onto the project. There was no choice about not putting this naming standard change in. The project manager was very concerned because he was an experienced Informatica developer, and he knew that such a change in an Informatica environment would take about a month's effort, and we were able to make that same change in about 4 hours in a SeETL environment, going through renaming fields and then regenerating the ETL subsystem and checking to see if it still worked. So in at least one case we have had the comparison of a month's worth of effort mandated onto a project being able to be completed in 4 hours with Informatica versus SeETL. And that's really because in an Informatica environment all the mappings are separate program objects. Now there can be, it's known that there are no bugs in the mapping code versus the mapping spreadsheet, because the bugs have to be in the mapping spreadsheet. And so there's only one place to go looking for bugs. The productivity gain is also very large, and there's a particular change that happens with when SeETL is used versus other ETL tools. And that is SeETL generates executable code which can then be run to run that portion of the ETL subsystem that has just been designed and documented into the spreadsheet. With ETL tools, that's not true. You have to design the piece of ETL and then you give it to a programmer to create the ETL component, and only after the ETL component has been created can you execute it and get some data to flow through it. Now, because of the typical waterfall approach and the fact that you know that you learn things as you go through the mapping process, there is a very great desire on the part of IT project managers for BI systems not to allow programming to happen in the ETL tool until the data is fairly well understood and the data model is fairly well stabilized. This means that data is not available in the data warehouse as a prototype until significantly later than in an ETL subsystem, a SeETL ETL subsystem development. What we are saying is with a SeETL ETL subsystem development, you get data into your prototype very, very quickly. And one example of this is that we did a client, and on the first morning of the first day, we demonstrated SeETL to show them how it works and what it can do. And on the first afternoon, we wrote 4-dimension table mappings and a fact table mapping of existing data to replicate it, to show the staff this is how it works. Now, if you were to go and talk to Informatica or IBM and ask them, could you on your first day of being on site install and have working data stage, give us a 3-hour presentation on it, and then write 4-dimension table mappings and a fact table mapping and show us how that all works so that we can become familiar with it, the guy from IBM or Informatica is going to laugh at you, because that's going to take a couple of weeks. Now, The funny thing about this client is when we came in on the second day and we said this is what we did on the first day, he actually asked us, why did you only do 4 mappings? And we went, normally you would take quite some time to do this. So it is actually possible to hit the ground running to that extent, where as soon as you know what data is in the staging area, you can start your mapping process. So there's the other thing that we see is there's no delay in coding, testing, changing ETL and models. That's a very fast cycle to go through each and every time. So once the data warehouse architect is happy with portions of the spreadsheet, he can just hit that build button and the executable output just appears. As I said, what we are seeing consistently is about a 50% cost reduction for the building of the ETL subsystem, sometimes more, sometimes less, but that's the ballpark that you should be looking at. Now, if you want to go into the detail of how SeETL works, we have now done a full 1-hour presentation on that, and you can actually see the actual generation of ETL, etc. And we have a full 1-hour presentation on video on the runtime component, so you can go through that to see how that works. So let's talk about the SeETL development project. These are real projects. So SeETL was used for the following system, which was a version 1.0 implementation of Sybase. 4,000 fields were in the staging area, and 2,500 fields were mapped through to the data warehouse, the Sybase data warehouse. There were over 100 dimension tables and 80 fact tables. There was over 10 million rows in the customer table. The memory mapped I/O for dimension tables was 1.7 gigabytes, and we were using AIX 5.1 and Oracle 9.2. We had sustained rates of 1,400 transactions. This was a telephone company, so CDRs. Sustained rates of 1,400 transactions per second per processor on that project, and that was the equivalent of 40 million transactions in an 8-hour batch on an 8 CPU AIX machine. Now that project was in 2004, and of course CPUs have sped up significantly since then. So on that project, the message was that SeETL design time plus SeETL runtime was up to the challenge of major data warehouse projects. If you can do a 10 million customer telephone company with 60 million CDRs per day, then there are not many companies doing more than that. Another SeETL project was for a major software manufacturer that sells software all around the world, and the headlines for this project, and this is not a typing mistake, there were 18,000 fields. The customer had 3 instances of Oracle applications installed around the world, one in Asia, one in America, and one in Europe. And the project was to bring 18,000 fields from each of those 3 Oracle application systems into a single integrated operational data store with all new keys, as well as over 650 new joins implemented between these tables to build a mesh that would allow us to join this data together more rapidly. So 18,000 fields with 220 tables in that staging area, or ODS as they call it, and we had around 200 million rows in the prototype, which was on Linux, and that was Red Hat Linux with Oracle 9.2. And yes, we were able to put the mapping for the 18,000 fields into a single worksheet, and we were able to generate the 440 plus views that were required out of that spreadsheet, and use the C++ engine to pump data from the staging area with all the key allocations done correctly into the single integrated ODS. So really quite something. in terms of building an ETL system from a staging area through to an ODS. We then did start work on the data warehouse side of the project, but we discontinued our relationship with that client during that period. So again, the message is that SeETL is up for significant or large data warehouse projects. Now, the current state of development is that we've added almost all required items to SeETL. We had a large development effort in 2010-11, which put a lot more things into the data warehouse, into SeETL, as well as vastly increased the complexity and options available for the SQL generation. So all source to target mappings with the generation code does not perform association tables, and we have to fix that. All the control tables required, all the jobs required, everything runs on Win 2003 up. We've just upgraded from our development environment from 2003 to 2008, so we're going to drop support for 2003 in the not too distant future. All the table view index definitions can be generated out of the spreadsheet. We can store documentation of stored procedures and functions in the database as well, and there are a vast array of things that are now stored in the SeETL workbooks. We are continually listening to customers to find out what they want next. We have another round of development coming, which is moving further upstream in the BI development process, where we'll have business requirements, critical success factors, project objectives, those kinds of things documented also into the SeETL workbook. So let's talk about SeETL runtime and the details of SeETL runtime now. Now remember, this is a C++ engine which is optional. You can use SQL generation or the C++ engine. It's really up to the customer. When this first was released, it was truly a miracle of modern programming. It was the ETL tool written by BI professionals for BI professionals. It delivers the promise of the 10 times productivity at 10% of the price, and has only recently been augmented, I should say, by the SQL generation process. So SeETL runtimes reads the definition of everything that's been done by SeETL design time and executes your ETL subsystem. SeETL is a complementary product to ETL tools, or an alternative to ETL tools for those companies that don't want to pay the money required for a vendor ETL tool. The best way to learn about SeETL runtime is actually just to go read the manual. But the summary is that the scheduler checks the batch prerequisites every n seconds, and you set n, and that is a set of parameterized commands that the scheduler runs. So as soon as the scheduler determines that some prerequisites have been met, it starts that batch, and that batch runs, and when that batch is complete, the prerequisites are turned off or met, and then the scheduler waits for some other prerequisites to be satisfied. Now there is one program per type of processing. So for example, there is one type 1 dimension processing program, one type 2 dimension processing program, one fact processing program, one fact association processing program. So what was done was the algorithm was abstracted from the data model, and what happens with each program is it's told what the source is, and it's told what the target is, and its first job is to open up the source and open up the target, compare the column names between the source and target, and build an internal map from source to target based on the column names. And so by doing that, there's no definition of the data structures stored within the program. Now, they can be run as command line programs, and integrated to other scheduling packages should you use other scheduling packages. However, we also have our own scheduler. It performs all the required processing even for large BI systems. SeETL runtime now may run quite complicated SQL statements. What are the three main features of SeETL runtime? Codeless, mappingless, typeless. These are the three things that you want in an ETL tool. Codeless. What does codeless mean? It doesn't mean that there's no code, for a start. What it means is there's no code that the end user has to write. So when you use DataStage or Informatica, you have to write mappings, and you express your ETL as mappings inside their graphical user interfaces. Their graphical user interfaces are code. They are expressing graphically code that gets generated at the back end. And so they are a code-based environment. Whether the code is shown in pictures or whether it's shown in something that looks like C++, it's still code. Inside SeETL runtime, there is nothing for you to code. We write all the code and we give you the finished code, and what you write is you write views over the source and target. Now, we know of no other tools. I won't say there are no other tools because we can't know everything, but we've never seen another tool that allows you to have codeless. So if you want new functions, what we do is we go and write new C++ development, C++ programs in Visual Studio, and we give back the type of processing with a whole set of parameters to drive it. So we have separated data structures and processing. In the vast majority of ETL tools, the data structure and the processing is collapsed together. And so if you need to write 100 dimension table mappings, you wind up with 100 programs. What we have with SeETL runtime is one piece of code, say type 2 dimension processing table, and then 100 source views and 100 target views. Now you can easily argue that what is in the spreadsheet is indeed also a mapping. However, that's just the source code for creating views. So by separating the data structures and processing and having one program for each type of processing, we've removed the need to write quote code for each mapping. So mappingless. What do we mean by mappingless? We mean that the ETL subsystem, the C++ engine, does not know of any mappings when it is created, and there are no mappings inside any metadata dictionary that it needs to go and read in order to understand how to map things. The only place the mappings are stored for the C++ engine is in the database manager, which you are going to source data from, and the one that you're sending data to. And they can be two different database managers, by the way. So this ability to do this kind of mapping without the mapping in a dictionary is unique. Nobody else does this. SeETL discovers the mapping at runtime. So the program starts, it reads the parameters for the source, which can be an ODBC DSN, which can connect to anything, anywhere, and the owner name and table name. So you connect it to a source via ODBC, you connect it to a target table via ODBC. Those two are views. It creates the map at startup time, and then it will move data, pump data from the source to target using that map for each row that's there. This is equivalent to the move corresponding for the COBOL language, except in COBOL and move corresponding that is done at compile time, and our map is generated at runtime. SeETL design time then ensures that columns that have matching names are moved, and so you can't make a mistake that way. And to add or remove columns, it simply requires before the spreadsheet, the add or removal of a field in a view, and after the spreadsheet you add a line to the mapping spreadsheet, and that will generate the appropriate create view statements, and that's it, you're done. You don't need to change anything else. So mappingless is the foundation of the order of magnitude productivity gains. Now you may then say, well, hang on a minute, in the SQL generation version, the mapping, the code, and the data structures are again collapsed. And that would be true. In the SQL generation version, the SQL language, which is generated, embeds both the data structure and the processing, which is why you end up with many fragments of SQL, and those fragments of SQL must be managed. In the C++ version, there are none of these fragments of SQL. All that SQL is generated at runtime inside the C++ engine. So what the SQL generation version is doing is fundamentally creating the situation where the C++ engine is emulated during the processing of during the creation of the SQL. Typeless. This is really great. SeETL runtime is actually unaware of any data types. It thinks everything is a string, except in rare cases where you tell it that these fields can be summarized and then they're treated as numerical fields which can be added together. So it moves columns based on name, and if ODBC can move the data to the target column using the implicit data conversions in ODBC, then that data will move. Okay. Whereas in a lot of ETL tools, the ETL tool itself is also sensitive to data types. So if the ODBC driver cannot do the data conversion through an implicit data conversion, then it will issue an error message and stop. So this ability to do the movement of data in a typeless fashion is really very good, because ODBC drivers can do a vast array of implicit data conversions for you. Now we do have metadata movement checkers and things like that to find out, is anything untoward likely to happen when we move data from one place to another. So there are tools provided to check data types, etc. So what this is doing is there's no need to check data types inside the ETL code, and there's no need to get rid of the data type mismatch messages that come in so many ETL pieces of software. Some other really nice features is that SeETL is not case sensitive, so parameters and movement of data and data comparison is all done in a case insensitive fashion. And so many times in ETL subsystems, when you push constraints or queries into the database, many databases are installed as being case sensitive because you want them to be case sensitive. But very rarely in an ETL subsystem do you actually want comparison of fields to be case sensitive. Now, because all the processing is performed via views, there are no restrictions on underlying tables. There are no data naming standards, table naming standards. One of the design points for SeETL was that there can be no naming standard required within the ETL subsystem or within the tables. Now, only ODBC data types smaller than 32K are supported. There's no chunking, so there's no graphics loading capability in the C++ engine. SeETL is fully null aware, so virtually any field can be null. Portions of primary keys cannot be null, but in moving things around, every field, every time, has got its null indicator next to it. Now, of course, the null indicator next to the field does carry a cost. However, that cost is usually well worth it. So things like change detection for type 2 dimension processing is null aware. So if something goes from having a value to null, that is detected as a change. Similarly, comparing two fields that are both null in SQL ends in not equal, but comparing two fields that are both null in an ETL subsystem, you want that to be equal. So those kinds of things are done within the C++ engine. SeETL includes a significant level of auditability, the number of rows processed, the start and stop times for rows, the rows per second, all those kinds of things stored away in the auditability area. The number of rows to be processed, we have a standard for how we capture the number of rows to be processed in this batch run, and then that gives us a fighting chance of finding out if all the rows have been processed. We have extensive error checking and reporting, and there are a large suite of error messages which come out of the SeETL C++ runtime library. How much is SeETL? Now, this is an interesting question because we vary the price depending on the size of the customer and how much processing they're going to perform. The reason being that small companies with not that much data and not that much revenue get less benefit from a business intelligence system than a large customer with large amounts of data or large amounts of revenue. So when we look at the pricing for a customer, we will price it according to how much we think the customer should pay for it, what we think is fair and reasonable, and we will discuss that with the customer. However, having said that, it will be roughly 10% of the price of a mainstream ETL product. So if you're getting a quote of €500,000 for DataStage or /Informatica, those kinds of tools, you should be thinking that we're going to be looking for about 10% of that amount. We will do everything that's needed to get your ETL subsystem implemented and built, and so you can then consider, do we want to buy the tool from the large vendor, pay the extra money and get a standardized tool, or are we willing to try out these guys from Instant Business Intelligence and pay a significantly lower amount of money for our ETL tool? You can purchase it in a number of ways. You can buy the executables only, or the executables plus source code if you want to maintain SeETL runtime. Design time is free. However, the SQL generation portion of design time is going to cost you the same amount as the runtime executables only. So prices are available on request, and we sit down and we discuss the price for each company. What you should be thinking about is you should have numbers in the range of €20,000 to €50,000 for a single customer site. If you're a consulting firm or you're a software firm who wants to embed SeETL, then we will sit down and discuss pricing with you. What do I get for my money? Pretty much everything that's on the website, plus the access to the runtime source code, if that's what you want. If you buy all the source code, you can bring SeETL into your organization as a piece of software that you own and can further develop for your needs. So we have customers who bought the software, have C++ programmers, have installed it in many, many accounts, and we very rarely hear from them apart from they pay their maintenance checks. The source code is heavily documented, and so it's very easy to understand if you're a C++ programmer. For annual maintenance, you receive Q&A support via email. Phone or on-site support is chargeable. Enhancements to the products as they are developed are then rolled out to you. But you get much more than code, and this is something we'd like to emphasize. You get access to 17 plus years now of being able to implement star schema data warehouses, and we have data models as well, which are the subject of other presentations. You get guaranteed a vastly reduced time and effort to implement star schema data warehouses. You get executable code that you know works. You know that if you create a view over this staging area and this view over this target area, you know that the runtime code between those two views does work, and you know that you don't have to check that code. You know you don't have to check the algorithm being used in that code. You get low cost maintenance because the majority of the configuration is via views, and you get all that at a negligible cost compared to today's ETL tools. As we said, it's roughly 10%. Why would I buy SeETL? 3 slides on this. I'm doing my BI project on a tight budget, and I don't have the money to buy a data stage, Informatica, ab initio at this point in time. Maybe we'll buy those things later. Or we are new to BI and our project sponsor wants proof of the value of BI in our company before he/she will spend the money to buy the infrastructure for the real BI system. SeETL is free as long as you're using it for prototypes. So in prototyping, we will give you a locked version of SeETL, and with set source and target names, you're welcome to build your prototype on those set source and target names and prove to your project sponsor that one, you know what you're doing, and two, what you're doing will be of value. Another reason, we are new to BI and we want to build our first few stars and learn how to do it properly before we spend the money to buy the infrastructure for the real BI system. And again, SeETL runtime is able to be purchased on able to be used free of charge during prototyping, and is only chargeable when it goes into production, and we have ways of implementing that. We have decided to use a combination of C++ and or DTS, now SSIS, to build our BI system. We're looking for some utilities that help us in that environment. And SeETL provides you a whole range of utilities inside that environment. Another one is, I have the money to buy an ETL tool, but my IT people already know C++, in case of the C++ engine option. In SQL, they will know SQL. And perhaps we can get our early work done without the ETL tool. Because I'm concerned that if I buy an ETL tool now, we'll just slow down the initial implementation while we learn how to use the tool. I'm concerned how much we might have to pay for external consultants to help us use that tool properly, and you can take it from us that when you buy an ETL tool like Informatica or DataStage, you do actually need help from somebody to learn how to use it and how to set up your standards and all those kinds of things. Or 3, I'm thinking we should get the first models up and running, prove the project, and then purchase the ETL tool when we know more and we're able to prove the value of it. Another reason that we don't hear so much anymore, because people have forgotten all about multi-level data, is we recognize the value of the aggregate keys for the summaries and the incremental update of summaries. We've been trying to do this in our ETL tool and found it is difficult, and we'd like to use SeETL, that's a typo, to support allocating keys and building summaries. Another reason is, and we hear this fairly frequently, our fact tables are changing on a regular basis, and it takes a long time to add new columns to the ETL for the fact tables we've had. We are interested in doing the bulk of the calculation work in our ETL tool, but populating the fact tables using SeETL because it automatically adapts to new columns with no code changes. Now, something that SeETL can do is if you add a column to a table and that column is in the work file, it will automatically be mapped and populated. Another thing is, if you add a key to a fact table and that key is in what we call an association table, which is linked to that fact table, that key will be automatically populated into the fact table with no code changes. So SeETL has some capabilities where it looks at what is available to go into this fact table versus what is desired in this fact table, and if the field is available and it is added to the fact table, that will be automatically detected. Nobody else does that kind of thing. Another reason is we already have our BI system up and running. We built it without an ETL tool, and now we're making changes and adding new data. We are looking at tools that might help us improve the processes that we have. So that's a good reason for buying SeETL. So how do I find out more? If you're interested, you go to our website and you download the packages on our products page or our downloads page now. In our downloads, we've now upgraded them such that there is a single package of about 27 megabytes, which brings everything down that it is that you need to evaluate all the different portions of ETL and of SeETL, and it has all the documents in it that you need to evaluate SeETL, not all the documents. So you can go to our downloads page and you can find out everything you need to find out with test data, with test spreadsheets and everything else like that. So you can try SeETL for yourself, see how fast you can write your own ETL now. We will warn you, and we're quite upfront about this, we will warn you that we take the model of low-cost provider. We're providing the software at the lowest possible price we can. We don't allocate time to spend with customers going through evaluation processes and all those kinds of things. If you want us to do that, we're happy to do that, and we want to be paid for our time to do that. The other vendors, our friends and colleagues at places like IBM and Informatica, are charging 10 times the amount for their software, and they will, quote, give you some free time, to help you evaluate their software. Our take is that our software is so straightforward and so simple that anybody with good ETL experience will be able to evaluate it. If you don't have that good ETL experience, then you should pay somebody to teach you how to evaluate it. So what's the summary? This presentation has just gone 71 minutes, and so the summary was this. We talked very briefly about ETL and what has happened in the ETL world, how we had started out with COBOL, and we've moved through a few engines, and now we've come up with something called SeETL. We talked about what is SeETL and who is it intended for, and then we went into a relatively light level of detail about SeETL design time and SeETL runtime. There is a vast amount of detail in other presentations. For example, in SeETL design time, there is now a 70-minute demonstration of exactly how you generate that SQL and the whole history of getting to SQL generation. And there's a 1-hour demonstration of the runtime engine as well, and you can go through that runtime engine. How much is SeETL? You should have in your mind between 20,000 and 50,000 euros, but it is a price on application, and we issue quotes to customers based on what we understand about that customer. Why would you buy SeETL? There were 3 pages of examples from customers as to why they have purchased SeETL. How do you find out more? You go to our downloads page on our website or our forums. The very first entry in our forums is also links to all the downloads. If you want to find out more about SeETL, we recommend you go to the downloads and start having a look at the videos, start having a look at the documentation, the standard spreadsheets, the standard databases, and you determine for yourself whether you think this is something that your company will want to invest in. We, Instant Business Intelligence, are not going to spend a lot of time talking to customers on an individual basis as to whether they want to use this or not. You're expected to perform your evaluation, or if you want us to help you with that evaluation and explain things to you, we will be expected to be paid for our time. So that's just gone 74 minutes. So I would like to say thank you very much for listening to this presentation. We appreciate your time and attention. We hope we have explained SeETL to you in such a way that you are interested in finding out more. Thank you very much.